teachers and students. Good morning, class.
Good morning, sir.
All right, thank you. You may sit. All right, quickly to recap on what we went through in our last lesson. We studied resistance in parallel, and you should have identified the differences that exist between a resistance or resistance in series and also the resistors in parallel. Now in this today's lesson we'll go through E.m.f and PD. Right? What does E.m.f stands for? Sulaiman.
Electromotive force.
Right. E.m.f is simply electromotive force. All right, for PD, what does PD stands for?
PD stands for the potential difference.
Okay, good. So PD is simply for potential difference. Right. Now, if you have to look at the force, okay, you have defined the that initial, which is E.m.f. But what is this electromotive force? Can somebody tell us what electromotive force is? Maima.
Electromotive force is the current that goes around a circuit.
It is the current that goes around the circuit. But what causes the current to go around the circuit? Really?
The voltage produced by a source.
Voltage from a source.
Cell.
All right, you can explain that in terms of current. What causes the current to move around in the circuit? Okay, it is a force that causes or pushes the current in the circuit. So in this case, electromotive force is a force that pushes the current in a circuit. Now, before the voltmeter has to start taking the reading, okay, the force that is produced is simply the electromotive force. All right, that is the definition of the electromotive force. All right. The force produced when the voltmeter is not taking any current from the cell. Or in other words, we can simply say it is a force that will push, especially the electric current in the circuit. Okay, without that force, current will not move or flow in the circuit. Right, so quickly write the definition of that term, electromotive force, and then we will go to the next slide. Okay, here is the next slide. Alright, the electromotive force is also measured in volts and is the total energy per Coulomb that is available from the cell. Right, looking at that, in our last lessons we looked at the energy which is given by Q times V. Right, looking at this V, then we can simply have the energy that is applied by each Coulomb of charge. So V equals to Q over E. And then when we have this will be 1V simply means that okay, energy or 1 joule of energy is given to 1 Coulomb of charge. All right, moving on. Okay, as you can see, there is a circuit. Right, there is if the cell is connected here, right, it will flow through in the circuit. Right, since the circuit is a parallel circuit, the voltmeter reading is now measuring the terminal difference or potential difference across the terminals of the cell. Right, it will have to measure this. So when the voltmeter start measuring, we can say that that is the potential difference. But before it start measuring that, it is the electromotive force. All right, so just get the diagram of that. All right. Okay, here is the next slide. All right, you find that the potential difference is always less than the electromotive force of the cell, because of the cell has some internal resistance. Now that means if you are calculating the voltage of a cell, now that cell has some kind of internal resistance. So in other words, that is the electromotive force. And actually, when you look at the circuit that you have copied, now you decide to measure the voltage, it will be less amount. It will be less than the amount of voltage that is produced by the cell. Okay, it will be before the last one or two information before I give you the activity questions to solve. Right, if we have finished, here is the right for the circuit. This is not a resistor. This is a cell. So electromotive force will be produced by this cell. Okay, and then when it starts flowing through, if the current is flowing through that way, that is a resistance. So in the diagram, the E.m.f. E volts and the terminal resistance is R ohms. Okay, you find that there is also, without this resistor being connected, there is also other resistance in the wire, especially in the wire. So that is why we have that small R, which represents that resistance. All right. Here is the next. Okay. As for that equation, when you are following that, the energy supplied from the chemical energy of the cell equals to energy delivered to the external circuit, energy that is wasted in the internal resistance. So the wire also has some internal resistance, and there will be some difficulty in current flowing through, so the energy will be lost. Right? Much of the common forms of energy will be heat energy, especially when you are connecting wires to electricity or cell. You'll find that as long as it lasts for a certain amount of time, it will become hot, the wire. Okay, that shows that energy is given, because there is some kind of difficulty for the current to flow through in the circuit. Right? Okay, I will give you the right. If we want to find the energy of the that is given of by the cell, you can use terminal potential difference plus loss volts. So that will be I times R, simply when you're calculating that, and then probably calculating the resistance that is lost, internal resistance, that is a small r here. So when you have to factorize, you come up with E equals to I, okay, big R, that is a resistor that is connected, plus the internal resistance of the wire. Okay, that gives you the amount of energy that is lost. Right after you copy that formula, that is the last information for electromotive force and the potential difference. Right here are the activity questions that you can go through quickly. Right, number one would be right, you have a dry cell or a battery of electromotive force which is 6, and the internal resistance is 2 ohms, and it's connected to a resistor or resistance of 4 ohms. So what current will flow through? The internal resistance will be 2 ohms. That is especially the resistance that is in the wire, connecting wire. And then you have the 4 ohms, which is from the resistors. Okay, using that, what current will flow through that conductor? Right, how do we find the energy of that? Can you tell us how you can find that energy of the cell? Right, when we are trying to use the equation, the last equation, that is E equals to I times Rn R, or R plus R.
The Coulomb dot equals Q times V.
Right, E equals to Q times V. And if you happen to find that 1 V is simply, okay, energy that is given to 1 Coulomb of charge. So in this case it is 6 volts, and that shows that 6 joule has been given to each Coulomb of charge. Right, you use that equation, E equals to IR. Internal resistance, you have 2, and then you have 4 resistor. So plus I is what you are asked to find. So energy, you know that it is 6 volts, so 6 joule. Yeah, that's right. All right, question number 2. You finished copying that question? Okay, here is question number 2. All right, a circuit that is shown there. All right, what is the combined resistance? What is the potential difference across the combined resistance? Right, there are 3 more questions that I will give you. So just copy those 2 first, including the diagram. Question 1, question 2A. Let me see, question 2B. Okay, question 1, question 2A, B. Here. 2C. Okay, I'll give you that later. Question number 2D. Okay, that is D of that. I'll give you later. And okay, you'll be last. 2E. Okay, here is question C, D, and E. Finish copying that. Okay, quickly have that diagram and the questions. 2 questions.
In this question, what is the combined resistance? We're talking about the resistance of this and this plus this. What is this?
Only for these 2. Because you don't find any up here. Unless it is given. Okay, question C, D, and E. Okay, 1, question 2B, 2C, 2C. Question 1, question 2A, B, and C. Question D and E. That's right. Okay. Because you know that in 6 volts, the energy will be 6 joules has been given to 6 Coulomb of charge. Following that, Q equals to okay. So when you explain in terms of that because there is no energy, but we can say that it is 6 volts. That shows that 6 joules of energy has been given to each Coulomb of charge. Therefore, using that equation E, then we solve for I. Alright, for question number 2, when you go for question 2, just the combined resistance of the circuit. Yeah. Okay, let me see. That is a tri-cell, variable voltmeter voltage. We can simply call it as. No, they are not resistors. They are dry. A voltable or source of this electricity. Okay, not resistors. Yeah. All right, for question number 2, you neglect internal resistance. So just use the circuit and then you solve for those, what you asked to find. You ready with question number A? Why? No, C will be 2A and then C. What is a P across 3 ohm resistor? Simply current is there. In PD, you use the Ohm's law. Okay. Yeah. To find the. No, for 3 ohm resistor, only for 3 ohm. Any questions? You finish? 2. Why? Okay. Let me see your question. What is the current to be? 3 ohm resistor. Yeah. And then when you calculate that, okay, the total resistance is, how many is total resistance is 2. So if you want to find the current, it will be, voltage would be I times R, so 2 times 6 will be 12. So in here, what did you get? Okay, the total voltage that is in the circuit would be, resistance would be 2, so it would be 12 volts. Yeah. So what is your, what is a PD across the 3 ohm resistor? What is the total voltage? Total voltage? Okay, 12. So PD across 12 ohm will be, V equals to I. Okay, so when you want to find the, because you already had the voltage, and then V equals to, you find the current flowing through there. I equals to, That's right. So you already find the current, and then that will be 4. V equals to IR total. When you find the total voltage, it is 12. 6 times the total resistance would be 12. 6 times 2. Okay. And then, okay, after you get the 12, you're trying to find the current through each one of these, because when it comes over here, you don't divide. So current in there will be 4 amps. 4 amps. Okay. I equals to, how did you get this? Okay, I equals to 12 divided by 3 is 4 amps here. And then using that 4 times 3, you arrive with 12. Okay, for the next one, if it is for 6, then current through there will be V equals to IR. So there will be V 12 divided by 6, and that is 2. And then 2 times what? 2 times 6 would be 12. That is the total current in the circuit without being, okay, it is not divided yet. When it comes over here, you'll find that half of that will be flowing there, half over here. But voltage in a parallel circuit will be the same in all parts of the circuit. Right? It does not. No, it is same in all parts of it. Yeah. Okay, we'll go through the correction. The first one will be Michael, and the others, please get ready to go out and then show your working out, and then you explain. All right. You get ready. Let me see you a second. Yeah, on. Yes. What is the PD across combined resistance? Okay, if it is a PD across combined resistance, then it will be 6 divided by 2, or 6 times 2. Okay, I times R, then you get 12. All right, you get ready.
For question 1, I use the formula E is equal to I brackets R plus R. And to find the current, you transpose the formula to find I, so it will be E over R plus R. So you know that the E.m.f is 6 volts. So 6 over internal resistance plus resistance of 4 ohms, so that's 4 plus 2, you'll get 6. So you divide that, 6 over 6 is equal to 1F. So that the current that flows is equal to 1F.
Right, that is for question number 1. Right, for question 2, what is the combined resistance? Jolene, quickly do that question. Michelle, you get ready. Maybe you can go in then. You write on the side of the board, but then after explanation, for the explanation, you go through and then explain. Let me see your question. Okay, what is the PD across the, what question is, what is the potential across 3 ohm resistor? Okay, but the voltage in a parallel circuit will be same in all parts of the circuit. Since you calculated this will be 6 times the total resistance, which is 2. Okay, that will give you 12. Now, what is the PD across 3 ohm? That is a 3 ohm. So first you have to find the current that is passing through there, because so I equals to V over, that is 12, because you know that 12 volts is been calculated, 12 over 3 ohm R. Then you have 4. And then using that 4,
The question is asking to find the
4 divided by,
combined resistance.
sorry.
So the formula is 1 on the total
what is the
resistance is
current
equals to
3 ohm resistor.
resistor 1 plus resistor 2. So to
I
get
equals
that,
V
we have
over R.
1 on
Yeah,
3
that is right.
ohms
So you have
plus 1
4.
on 6 ohms.
Then you
And
have
then 3
4
into
times
6 goes
which is
2.
equals
2
to-
times 1 is 2 plus 6 into 6 goes 1 times 1 is 6. And then we get 3 on 6. The reciprocal of that is 6 on 3. And you divide 3 into 6 and you get 2 ohms.
Okay, good. 2 ohms is the total resistance in the circuit. That is the combined resistance. All right, quickly we'll have to 2C. Okay, it's 12 divided by 3 equals to 4. Then you
Find
have
the
4 times 3
potential
again
difference.
will
You
give you the
multiply
4
the
times
total
3, which
current
will give you
with
the
combined
voltage,
resistance,
voltage
which is
across
6
there.
times 2, and you get 12 volts.
All right, the PD across combined resistance will be I times R, and then you have 6 times 2, which is equals to 12 volts. All right, for question C. All right, just get the marker you write answers. Charlton, you get ready, and then Solomon.
The question asked to find the potential difference across the 3 ohm resistor. Voltage is equals to I times R. So the current is 6 multiplied by is 2 to give you 12 volts. And to find the current, you get 12 divided by 3 will give you 4, and multiplied by 3 to give you 12. Sorry, it's 4. 4 amps.
Okay, that the answer would be 12 volts. Right, 4 amps is the answer to current that is passing in, okay, this circuit. Right, 4, so that means 4 will be passing there, and then this one will have 2 amps. So we have this one as 4 times 3, and then that gives you 12 volts. All right, Charlton.
To find the current of the circuit, the formula used is current equals voltage over resistance. The voltage is 12, the resistance is 3, so therefore my current is 4 amps.
All right, current through a 3 ohm resistor will be 4 amps. Solomon. Okay, you can just stand up. You still want to calculate that, right?
In order to find the current, I use the same formula as used in D. Voltage over resistance, 12 volts on 6 ohms to get 2 amps.
All right, good. So you can come up with calculation to verify what you were given. Right, when it comes to the 3 ohm resistor, all right, you have 4, meaning that there is less resistance and therefore 4 amps will be passing through. But when it comes to the 6 ohms, there is lots of resistance, so only 2 amps will be passing. But if you want to calculate the voltage, it is the same in all parts of the circuit. Right, even if you have to use it, if you want to calculate the voltage of this, okay, let's find out. So we have this as V equals to I, that is 6 times 2. And that gives you, all right, 12 volts. All right, quickly going through the summary of what we just discussed in the lesson, right, especially the E.m.f or the electromotive forces, the force that pushes the current through the conductor. Now, before the voltmeter has to start measuring the voltage, right, the voltage that is given by the dry cell or the cell is simply the electromotive force, but it has some kind of internal resistance in it. Now, as it flows through a conductor, and if you decide to connect resistors, those are the normal resistors which will be measured, but then the wire has its own resistance or internal resistance. So when there is a question with us, which may ask you to calculate the resistance, right, sometimes you have to ignore the internal resistance of a conductor and then given only the resistors or resistance of the resistors. Now, using that, the formula which is E equals to I times R plus R, that will give you the total resistance in the circuit. So that is how you can calculate especially the amount of energy that is given out to each coulomb of charge. So when you are given or measurement of the voltage, it shows you the amount of energy that is given to each coulomb of charge. Right, so that is the end of our lesson. Our key phrase for today will be okay, E.m.f and
Terminal PD.
okay, terminal PD. Right, you can all stand up now. Good afternoon, teachers and students. Good afternoon, class.
Good afternoon, Mr. Saraman.
All right.